Hey math people, I'm trying to save all the math teachers out there in this universe that have to deal with the dreaded this error. The quantity of a plus b all squared is equal to a squared plus b squared. That was me just shuddering a little bit inside. This isn't, no, don't do this. Let me explain why, and let me actually show you what you may be thinking of too, that may also shed some light. Let me show you why. We have to actually draw to geometry for a little bit of inspiration here. So consider x squared, all right? We know that x squared is just is just x times x, right? We can actually draw this as a square, hence x squared. X times x is x squared. Now, a plus b all squared, that's a little different. And it's certainly not going to be a squared plus b squared. Let's go to the geometry approach first, then write down our answer here. This will be a plus b times a plus b. Now would you wait a minute? I have two terms here and two terms here. I can think of this length as a, and this length as b. And I can do the same exact idea on the other end. This length is a, and this length is b. So looking at this top left box, I can do the same exact approach I did over here. This is a squared. Looking at this bottom left box, I have this b times this a, so this little area will be ab. A times b is ab. I have this bottom right box, this little b times this little b, it's going to be b squared, just like how it was over there. And then top right, I have AB again, A times B. Sometimes you factor using these boxes, called box method when you factor. I'm not sure if you got to that yet, but regardless, the geometric approach is nice. We can add up the sum. So the sum of the parts is the whole. It would be then A squared plus, well, I got two ABs here. I got this AB and this AB, so we'll say 2AB plus B squared. You forgot about this 2AB part. What you may be thinking of is when you're multiplying A and B together. So, alternatively, what if you're dealing with AB all squared? What is this equal to? Here, you can do that thing you tried to do. You can do it here because it's multiplication. The way that we think about exponents is we can write them out twice, just like how I wrote out this inner piece twice over here. And I could have over here, I could have said this is AB times, or A plus B times A plus B. FOIL is something that some teachers teach, by the way. So I just FOILed, but I used a box for it. Anyway, writing out exponents, you can just, well, exponents is the idea of repeated multiplication. So this is equal to AB times AB. These parentheses here are arbitrary. You don't really even need to think about them at all. It's the same thing as A times B times A times B. I have two A's being multiplied by one another. I have two B's being multiplied by one another. Here you can just do A squared, B squared, because it's multiplication on the inside. When you have addition, when you have multiple terms, you need a FOIL, or you need to use box method, or whatever. You need to use distribution property. That's what it's really called. And then over here, well, it's multiplication. This is a single-termed expression. You can do that little distribution of the square, but be careful with that. Mind your dear Aunt Sally. Oh, thank you for playing Math On. I will Math On. You do the same, whatever. Bye.